Hello and welcome to helpyourmath.com. In this video, we're going to look at arithmetic sequences, which is an application of inductive reasoning. By now, you should already know what an arithmetic sequence is. It's a sequence that has first term, no last term, and to get from one term to the next, you add the same amount called the common difference. Okay, so there is a formula we can use to find any term in an arithmetic sequence, but we do have to discuss the notation first. So this a sub 1 is the first term in the sequence. That's pronounced a sub 1, indicating that 1 is the subscript. Not is a subscript, is the subscript. We're going to say the. So subscript is like the opposite of an exponent, although it has a very different meaning. You've seen subscripts before. If you've ever used the slope formula, you know y2 minus y1 over x2 minus x1, the 2's and 1's, those are also subscripts. All right, next we have a sub n. That's the nth term in the sequence. D is the common difference, and n is the number in the sequence. So the formula to find any term in the sequence is a sub n's, that's the value of the nth term of the sequence, is equal to the first term, a sub 1, plus the common difference times the number in the sequence minus 1. So as long as we know 3 out of 4 of these variables, we can figure out that missing piece. Let's look at some examples. We're given 6, 14, 22, 30. First, we're going to write a formula for the nth term, so that's for just the generic any term. And this, again, going back to that previous slide, this is a sub n. And then we want to find the 10th term. Okay, so for part A, let's write down that formula. A sub n is equal to a sub 1 plus d times n minus 1. And let's fill in everything we know. Now we're writing a formula to figure out a sub n, so I assume that that is unknown. This a sub 1, that's the first term. The first term in the sequence is 6. D is our common difference. While it's not given to us, we should be able to figure it out. To get from 6 to 14, I would need to add 8. To get from 14 to 22, I would need to add 8. To get from 22 to 30, I would need to add 8. So our common difference is 8. And then we're looking for n. Now, temporarily, we're going to leave n as an unknown because the n here and the n right here, the subscript, is the same number. So since part A is just finding a generic formula, we're going to leave n alone. So this is going to be a sub n is equal to 6 plus 8 times n minus 1. And this way, as soon as we have a value for n or for a sub n, we could figure out the missing variable. Okay, so now we're going to find the 10th term in the sequence. Now we have 1, 2, 3, 4 terms, so if you wanted to, you could just keep adding 8 a bunch of times until you figure out the 10th term, but we're going to use the formula. We're going to do this the mathematical way, not the like cheaty, I'm just going to keep hitting equals on my cell phone calculator way. All right, so we're going to replace here, n gets replaced with 10. So we say a sub 10 is equal to 6 plus 8 times, and again, n is 10, 10 minus 1. Following order of operations, that would be 10 minus 1 is 9. And then order of operations says we're going to multiply first. That would be 72. 6 plus 72 is 78. So we would say that the 10th term, the value of the 10th term, is 78. Our next example, given the 25th term of an arithmetic sequence is 4 and the common difference is negative 9, find the first term. So this example is a little bit different than the last one because we don't know the first term. So let's see what we know. 25th term, so what we know is that n is equal to 25 of an arithmetic sequence is 4. We also know that the value of that 25th term, so a sub 25, is 4. And we know the common difference is minus 9. We want to find the first term. So a sub 1 is our unknown. Looking at the formula, that would be a sub n is equal to a sub 1 plus d times n minus 1. We're going to fill in the variables that we have. We know a sub 25 is 4. A sub 1 we don't know, so we'll leave it a sub 1. D we were told is minus 9 or negative 9. N is 25 minus 1. So now from here, let's follow order of operations. So we're going to clean up this whole mess over here. 25 minus 1 is 24. And 24 times 9 is 216, but this is negative 9, so it's negative 216. Now to get a sub 1 by itself, we need to add 216 to both sides. And that gives us a grand total of 220 is our first term. And that's what it asked us to do. So 220 would be our answer. A few more practice problems in case you need them. Given the sequence 82, 73, 64, 55, write the formula for the nth term, and then find the 24th term in the sequence. Okay, so let's label what we know. We know a sub 1 here is 82. We know the common difference. Well, we don't know it, but let's see if we can figure it out. To get from 82 to 73, I would subtract 9. To get from 73 to 64, I would subtract 9. To get from 64 to 55, I would take away 9. So the common difference is negative 9. And then n is our unknown, so we don't know n or a sub n. So we're going to have a formula that relates to unknowns, which makes sense. So when we plug in, we have a sub n is equal to a sub 1 plus d times n minus 1. We would say a sub n is equal to 82 plus negative 9 times n minus 1. This would be the formula, so this would be the answer to part A. For part B, find the 24th term. This time we know that n is 24. So we would say a sub 24 is equal to 82 plus negative 9 times 24 minus 1. We'll follow order of operations and clean this up. A sub 24 equals 82 plus, this is negative 9 times 23. Negative 9 times 23 is 207. And that would be negative because of the negative 9. Let's try that again. Great. And then 82 plus negative 207 would give us negative 125. So the 24th term in the sequence has a value of negative 125. And again, you could just sit there and keep hitting equals on your phone or calculator or whatever, but that would be a lot more work than just plugging into the formula. So it's nice to have the formula, but it's also nice to have options, whatever works for you. All right, given the sequence, negative 6, 11, 28, 45, we're going to write a formula for the nth term, and then we're going to find the 10th term. If you haven't been trying these by yourself, I suggest you hit pause now, try it first, and then you can compare with what I go over. Okay, so let's get started. Our first term here is negative 6. The common difference, to get from negative 6 to 11, I would need to add 17. To get from 11 to 28, I would need to add 17. To get from 28 to 45, I would need to add 17. I'm seeing a common difference here of 17. So it's positive 17. Those are the two pieces of information we need to be able to write the formula. So the formula given this would be a sub n is equal to the first term plus the common difference times n minus 1. So there is our beautiful, majestic formula, and this is the answer to part A. For part B, we want to find the 10th term, so now we know that n is 10. Let's plug in. A sub 10 is equal to negative 6 plus 17 times 10 minus 1. This would be a sub 10 is equal to negative 6 times 17 plus 17 times 9. And this would give us negative 6 plus, that would be a 3, 6, 153. When we add those together, a sub 10, we get 147. So the 10th term is 147. Okay, and our next example, given the 32nd term of an arithmetic sequence is 735, and the common difference is 13, write a formula for the nth term. So if we're going to write a formula, remember we need two things. The common difference, which we have. Try that again. Common difference, which we have. And the first term, which we do not have. So let's write out what we know. The 32nd term, so n is 32. We also know that a sub 32, a sub n, is 735. We also know that the common difference here is 13. So let's figure out that first term, because if we're going to be able to do this, we need a sub 1. To figure out that first term, we're going to plug everything we have into the arithmetic sequence formula. So it would be 735 is equal to that first term plus our common difference, which looks like the letter B. Let's try again. 13, there we go, times n minus 1, 32 minus 1. So this is 735 is equal to a sub 1 plus 13 times 31. That would be 735 is equal to a sub 1 plus 31 times 13, which happens to be, 13 times 31 is 403. Then to get a sub 1 by itself, we'll subtract 403 from both sides. And we get a sub 1 is equal to 332. Now that we know the first term, we can plug in the first term, so we need this and we need the common difference to be able to write the formula. So the final end result would be a sub n, we go back to the generic because we're writing the formula, equals that first term, 332, plus 13 times n minus 1. And we could check our work because we could make sure that if we did plug in 32 for n, that we do end up with 735. If that doesn't work, we made a mistake with our formula. In our last example with arithmetic sequences, given the 47th term of an arithmetic sequence is negative 126, and the first term is 242, write the formula for the nth term. So at this time, if you haven't practiced yet, again, I would encourage you to hit pause, try this on your own first, then come back and check. Did you try it? Really? Did you really try it? Okay. So we're going to label everything we know. We know the first term is 242. So if we're going to write a formula, we need two things. The first term, which we have, yay, and the common difference, which we don't yet have. So we're going to take what we know and we're going to plug it in. A sub 47 is negative 126. Our first term is 242 plus our common difference we don't know, and then n minus 1. This would give me negative 126 is equal to 242 plus this would be 46 times d. We're going to subtract 242 from both sides, 242, and that gives us negative 368 is equal to 46 times d. To get d by itself, we would divide both sides by 46, divide by 46, and we see a common difference. It would be 368 divided by 46, which is 8. It's always nice when you get integers because it's like, yeah, I think I did something right. This is a negative divided by a positive, so it actually is negative 8. Now, we can verify that this does make sense, that the common difference is negative. What that tells me is that the first term should be bigger than every other term in the sequence, which it is, so it makes sense that the common difference is in fact negative. Now, it did ask us to write a formula, so the formula, remember what we need? The first term and the common difference. So when we plug in, we would say a sub n is equal to 242 plus negative 8 times n minus 1. And this will allow us to find any term. And again, we could always check our work by plugging in 47 for n and making sure we end up with negative 126. Thank you for stopping by.